Hello, everybody. We're going to continue going through 2015. I seem to have a really good internet connection right now, so I'm trying to go through as many videos as possible before things start to crash on me. So this is question 5. You may have already gone through 3 and 4 already if you're going in order. Question 5, I really liked question 5. I know that might not be the general consensus from you guys, but I liked it because it was a really good example of curve analysis. I even wrote that down as soon as I started reading it. Curve analysis was something we did in chapter 3. We did all the curve sketching in chapter 3 when we used our characteristics to draw it, but then we also worked backwards, and that's what this is. So the first thing I did is I kind of read over the initial information. I will admit there was a lot going on here that I thought was kind of overwhelming, but I did put some marks. I can see where it crosses or touches the axis. I also put little marks at your high points and your low points, your extrema, -1, 1, and 3. And then the last piece of information talked about the area under the curve. So the area from -2 to 1, it said was 9. So I put a 9. I also put a negative just because it's under the axis. And then same thing from 1 to 4, they told me the area was 12. I put a negative in front of it to remind myself about the location. So then I get to what the question's asking. Parts A, B, and C were all curve analysis. Part D was the only part that wasn't. Part D was more of a chapter 4 fundamental theorem question. So part A wanted to know what x coordinates does it have a maximum? So when you're doing a curve analysis, you're looking at the location of the derivative because that's what you're given. You're given f prime. If it's above the x-axis, meaning the derivative's positive, you're increasing. If you're below the x-axis, that means it's negative, then it's decreasing. And when it switches, we have extrema. So the only place it switched in this interval was right here at -2. And what's happening at -2 is the derivative was positive before and negative after. So if you think about that in terms of a picture, positive means you're increasing, you're on your way up. Negative means you're decreasing. So that's going to create a maximum. So the way that I said that, and there's a couple ways to say it, I'll show you mine, I'll show you theirs, is I wrote that -2 is a relative maximum because prior to it, you have a derivative that's bigger than 0, and after it, you have a derivative that's less than 0, so it's a maximum. What they said is they talked more about kind of the sign switch specifically. They said that they listed the places that we had a 0 derivative. I don't think you need that because -2 is the only one they're giving you credit for identifying. But their justification was since the derivative went from positive to negative, it has to be a maximum. And that's another great way to say it. Their way was probably a little more concise. So if you said -2 was a possibility, first of all, and then you explained why it's a maximum, you get the second point as well. Part B wanted to know when is the original function concave down and decreasing. So the first thing I wrote down is what does it mean to be concave down and decreasing? So f is concave down when the second derivative is less than 0, and it's decreasing when the first derivative is less than 0. I'm essentially looking for a negative first and second derivative. So if I'm looking at a picture here, the first derivative is negative anytime it's under the x-axis. So basically everything here from -2 to 4 is negative because it's under the x-axis. As far as when its derivative is negative, when the second derivative is negative, it needs to have a negative slope, meaning it has to be decreasing. So just from a strictly visual standpoint, from -2 until it gets to -1, it has a negative slope because it's dropping, and it has a negative value because it's under the axis. So that would be one interval. And then it happens again from 1 to 3, because again, negative slope means its derivative is negative, and negative location under the axis means its original f prime is negative. So here's how I said that. I wrote it down. So I'm looking for the double prime to be less than 0. I'm looking for the original to be decreasing, negative slope. Here's my intervals, and this was my explanation. I think it was good enough. My explanation for these being my answers is those are the places where both the second derivative and the first derivative were less than 0 or were negative. They did say open intervals, which means you don't need brackets around any of these. You could leave it as just parentheses. For their scoring, they gave 1 point for the intervals. So if you identified the intervals, they wrote it differently than I did it. They used less than notation. And then your reason. And their reason, they said f prime is decreasing and negative. You could say f prime and f double prime are both negative. There's a lot of ways you could say that. And then part C, let me read it, was looking for points of inflection. So when you're doing a curve analysis, your points of inflection are going to be anywhere that you have extrema on the first derivative graph, because that's going to be where the derivative of the derivative changes signs. So that's going to happen at -1 because the derivative goes from decreasing to increasing, which means your second derivative changes signs. This happens again at +1, and it happens again at +3. So my explanation First, I wrote down my points of inflection are going to be anywhere the second derivative is 0 or undefined, and the second derivative has to change signs. And that happens at -1, it happens at +1, it happens at 3, and I wasn't real specific on these. They were actually a little more specific. I just said these are all the places where the second derivative has a sign change. They separated them, which I don't think is necessary because there's not different types of points of inflection. They said -1 and 3 were points of inflection because the derivative went from decreasing to increasing, and then 1 also was because the derivative went from increasing to decreasing. Usually, as long as you explain that there's a sign change with points of inflection, they're not really picky on that. So you get 1 point if you identify all 3, and then 1 point is however you chose to justify that. And then finally, part D, which was the only part of the question that was not curve analysis, gave you an initial condition, essentially, told you that f of 1 equals 3, and wanted you to write an expression for the original function. They gave you a hint that it had to involve an integral, and that you were going to use that to find f of 4 and f of -2. I think there was one piece that might have been tough to this, and it was trying to figure out the boundaries. So when you write an integral, you know you're integrating f prime, because if you integrate f prime, you get f. Your boundaries are what you know and what you need. So you know the boundary should be 1. The other boundary, I think what they wanted you to do was just be really generic and call it x. And then you could go back later and figure out what happens when your other boundary is 4 or -2. So that's how I treated it. I wrote it like this. My integral is going from 1 to x, because again, that value is changing, of f prime. And when I integrate f prime, I get f, and it's top minus bottom. I wasn't sure if that would be enough because they kind of seemed like they want f of x by itself. So to get f of x by itself, I added f of 1 to the other side. So I wrote it like this. The reason I put it in front is sometimes when you put something after an integral, it gets confusing because you're not sure if it's something you're supposed to integrate. And then at that point, I know f of 1 is 3, so you could put a 3 in there if you'd like. I then started to figure out what is f of 4 and what is f of -2. So f of 4 would be the 3, which was that initial value, plus the integral from 1 to 4 of f prime. Well, the integral from 1 to 4 is this piece right here. It would be -12. They told us the area was 12, but the location makes it negative. So you end up getting 3 plus a -12, which ends up giving you -9. And then for the second part, when you had to find f of -2, you have the same thing. You have that initial 3 plus your integral from 1 to -2 of f prime. Two things with this. You are going to have to find area, so I'll go up and do that. The boundaries are also flip-flopped. You should have -2 actually on the bottom. What that does is it negates your answer. So if you go up to your area, now they're talking about the area right here. The area is 9. It's under the x-axis, so it's negative. However, because of the boundary switch, it's actually going to be considered a positive 9. So that's why I circled my boundaries here. So I have the 3 plus 9, you get 12. So here's how they scored this. I thought this was the toughest part, and they did make it worth the most points. You got 1 point if you had your integral set up correctly. I think what that means is as long as you knew to integrate from 1 to some x value, the one thing that I mess this up all the time, you really shouldn't write, like I wrote f of x. Math really picky people would not be happy with me. You should not have the same variable here as you do here. So that's why they wrote it with t's. I make that mistake all the time. So if you have your integral, you get a point. Somebody really picky might have not given me that point. Then if you have your integral expression, which your integral expression is, did you put the 3 in? I think as long as you have something similar to that, you'd be fine. And then they only gave 1 point for these two pieces, so it's kind of an all or nothing, which was a little frustrating. So you had to have -9 as what you get when you put 4 in, and you had to have +12 as what you get when you put -2 in to get that third and final point. So I'm hoping they're a little lenient with this stuff, knowing that full well it was kind of tough to get the full credit for that last one because it had a lot of things going on. So that was question 5. Really good curve analysis with a little bit of chapter 4 at the end, which I liked. And then I'll continue with number 6 next. Thanks.